Hey, this is Mr. James, and in this video I'm going to show you how to do transformations, that's translations, reflections, or rotations, three different ways. Right? And to do that, basically I'm going to take the same worksheet right here, and I'm going to do it three different ways. Once I'm going to use transfer paper, or patty paper, wax paper, or parchment paper, as you might know. Second, I'm going to do it again using properties of transformations, the things we know about transformations, about reflections or rotations. And third, I'm going to use an algebraic map to do these things. Remember, an algebraic map looks something like this. X comma y goes to maybe x plus 2 comma negative y. Things like that is what I'm going to use. So let's start with probably one of the easiest and most successful ones, transfer paper. Now, transfer paper is good because you can just simply take a piece of transfer paper and outline your shape like this. Okay, you've got A, C, and B right there. And simply just move it the way that the transformation is telling you to. This says translate down 2 and to the right 3. So I'll just take my triangle and know that translate just means to slide or to shift. So I'm going to slide or shift down 2, 1, 2, and to the right 3, 1, 2, 3. There it is. And that is where my new triangle should be. So let me go ahead and draw that. Okay, let me again remember, sorry, 1, 2, 1, 2, 3. Okay, so A ends up there, C ends up there, and 1, 2, 3, 4. B ends up here, and again, because they're the images, I'm going to put prime next to them. And so you can see them a little better, I will outline them in some pink right there. Okay, there's my image. I can do the same thing with reflections. I'm going to start with the same transfer paper, and this time I'm going to reflect over the x-axis. So we can see it a little better. Here is the x-axis right there, and I'm going to draw the x-axis on my transfer paper right here. Just like that. And I can see that to reflect, I'm going to take my transfer paper and literally flip it over and reflect, line that x-axis back up again, and boom, there it is. There is my reflection. All I need to do is now draw that in. A prime, C prime, B prime. Again, take the pink so you can see this a little better. There's my image. Now it gets a little trickier if we're going to try and reflect over y equals x, but still not too bad. Got my transfer paper again, and this time I'll erase, erase, erase. And where's the line y equals x? Remember, the line y equals x has a y-intercept of 0 and a slope of 1, so it should be right about right there. Y equals x. And this time I will just trace the y equals x line gently on my transfer paper. And then, same as before, flip that over and line it up. And there it is. So my image is right there. So just copy that over. C prime, A prime, and B prime. Connect it again with the pink marker. And there is our image. Very nice. Lastly, we could rotate even with this transfer paper. 90 degrees counterclockwise, and it doesn't say so, but we're going to do this around the origin, the point 0, 0. So, take your paper, take your pencil, press it down to the origin, and rotate 90 degrees counterclockwise. That'll be in that direction, going this way right here. So counterclockwise. And it might actually help to draw these axes a little bit so we can see them. Okay. And that is 90 degrees right there. All right. So that's all there is to it. B prime, C prime, and an A prime. All right. There they are. There they are. And so that's an example of how to do some transformations using transfer paper, also called patty paper. Now, the good thing about this is it's very visual. It's kind of easy to use. However, we're not always going to have transfer paper with us. So we're going to need some other ways to do this. Next, I'll show you how to do some transformations using the properties of transformations, kind of the definitions and what we know about how they work. Now we're going to do some transformations using the properties. So what do we know about translations that can help us do this? Well, we know that whenever I translate, it moves all of the points the same amount. So for example, if I only move 1 point, say I move B, down 2, and right 3, 1, 2, 3, B prime will be right here. But I know, because I know that a translation will move all the other points the same way. So instead of counting for C and counting for A again, all I've got to do is know that C is 1, 2, 3, 4 over. So I go 1, 2, 3, 4 over from B prime to get C prime, and A is 2 up. 1, 2, 1, 2, connect my points, and there is my image. For reflections, I need to think of the properties of reflections. Well, I know for a reflection, the distance from the any point on the pre-image to the line of symmetry will be the same on the other side of the line of symmetry. So if I count, B is 1 away, so on the other side, here's B prime. C is 1 away, so here is C prime, 1 away on the other side. A is 1, 2, 3 away, so on the other side, 1, 2, 3. And, oops, sorry. 1, 2, 3, there's A prime. Connect my points, and there you have it. What about for reflection over y equals x? Well, this one is a little tricky. We can still use the properties to figure this one out. We know that the distance from the line to each point of the figure of the pre-image is going to be the same on the other side when we draw our image. The other thing we know, and this may be, you may not know this, is that the line that connects the pre-image and the image must be perpendicular. So think about this. If I've got a line going this way, right, with the slope of 1, the line perpendicular would have a slope of -1. So I'm going to have to count in this direction, right? This -1 slope. So if I count, I have to go that far to get to B. And so on the other side, I'm going to have to go the same distance to get to B prime. For C, using that kind of slope of -1, 1, 2, 3. So 3 of these kind of diagonal squares, perpendicular again, 1, 2, 3, and I get to C prime. A, 1, 2, 3, 4, it seems like. So 1, 2, 3, 4 on the other side, and I'll get to A prime. Okay, connect my points, and I see a reflection. And again, you can kind of visually see that, yeah, this is a reflection of that triangle across the line y equals x. Then lastly, what properties can I use to rotate 90 degrees counterclockwise? Well, I know that I'm going to have a center right there. And let me think about these axes. Well, if I have this axis right here, right, what's going to happen when I rotate that axis 90 degrees counterclockwise? Well, it's going to move to this, I'll kind of dot it, this new axis. So when I rotate things, okay, I know that even though things are going to spin around, the distances between everything is going to be preserved. So for example, this right here, C, is 1 unit away from the x-axis, which means that when I rotate it, it will be 1 unit away from the y-axis. So here's C prime. B is 1 unit away as well. Okay, so it'll be again be 1 unit away. There's B prime. A is above C, 3 units in. So 1, 2, 3. There's A prime. Connect my points, and there you have it. Now we've just done a bunch of transformations using the properties of transformations. Just to recap, here are the properties that we needed. We needed to know that when you're doing a translation, every point is moved the same distance, right? Sometimes we call that a vector. So the vectors from the pre-image to the image are all exactly the same, and they also happen to be parallel. So you can easily move one point and then move all the other ones according to that first one. The second property we used is the fact that in a reflection, the distance from the pre-image to the line of symmetry is the same as the distance from the image to the line of symmetry. Okay? We could say that this line of symmetry is a bisector. Okay? It cuts these two, the distance between these two images, in half. If I were to draw a line right here, lines maybe connecting B and B prime or C and C prime, this line would bisect or cut those segments in half. And this would be what we could call a midpoint. We also learned that it's not just a bisector. The line of symmetry is more than a bisector. It's a perpendicular bisector in that These segments that connect B and B prime or C and C prime are in fact perpendicular to that line of symmetry, which is very important, especially when you're reflecting across. I think the video froze, so again, we got our line of symmetry, and it's a perpendicular bisector to the segments connecting things like C and C prime. And lastly, with rotations, we learned that you've got a center, and when you rotate it, you can say that the distances between the axes and any of your image and your pre-image will be the same, so that we use that to help us rotate that. Next, what we're going to do is use algebraic maps to help us translate some of these points. First, let's do a translation. The map for this one would look like this. It always starts with x comma y as a starting point, and what are we mapping to? Well, if we're translating down 2, that is negative 2 in the y direction, and right 3 would be positive 3 in the x direction. So we'll write x plus 3 and y minus 2. Okay? So that means I can take any of these coordinates and use this to find where their new, where the image will be. So for example, if I took C, C is at the point negative 5 comma 1. Negative 5 comma 1. If I want to find where the new C is going to be, the C prime I guess, we could plug negative 5 and 1 into this map. So let's see, negative 5 plus 3 leaves me with negative 2. 1 minus 2 leaves me with negative 1, which means that C prime will be at negative 2 comma negative 1. So if I draw that in, negative 2 comma negative 1, there's C prime. You could do this with all the other points and find out where A prime and B prime will be. And that is how you use an algebraic map. Maybe it's not the most useful thing with translations, but it's definitely helpful with reflections. If I'm going to reflect this over the x-axis, that's going to mean that, well, moving up and down, my y values will go from positive up here to, boom, negative down here. But I'm not moving left or right, so those values won't change. My x values won't change, no left or right. So my map for this one would look like this. xy maps to x, that stays the same, and negative y, because that y will be flipped over. So taking a point like C, which is at, again, negative 5 comma 1, and using this map, C is going to end up, keep the negative 5, keep the x the same, and change the 1 to negative 1. That point ends up being right here. If I were to find the coordinates of all the other points and put them through this mapping, I would find B prime to be here, and A prime to be right here. Reflection over y equals x has the mapping x comma y to y comma x. Now, if you're having trouble remembering that, there's a couple things you could do. Number one, you can memorize the different mappings off of this sheet. And this is the sheet that we did in class. You can think, oh, y equals x means that those two variables will be equal, and so I can switch them. Or you don't use this method. You choose a different method, either the transfer paper or using properties of transformations. In any case, let's see what happens to C here. So C, again, is the point negative 5 comma 1. So under this mapping, it would change to 1 comma negative 5. Those would be switched. So I go to 1, negative 5. There's C. And if you do this mapping to all the other points, you will quickly find out that your triangle looks something, like this. There's A prime, there's B prime. So the last one is rotating 90 degrees counterclockwise. And this mapping is a little hard to remember. In fact, I need to look it up right now for myself. Yep, rotating 90 degrees counterclockwise is negative yx. So negative yx, which means I'm going to switch my, my coordinates and make the first one negative. So C is at, again, negative 5 comma 1, which means that my C prime will be at negative 1 comma negative 5, which you'll see negative 1, negative 5. There's C prime. And if you map all the other ones, you'll find out that your triangle ends up looking something like this. For the majority of our quiz and tests, you'll be able to use any of these three methods, but there will be specific questions where you need to know how to use all three methods, using transfer paper, the properties of transformations, and an algebraic map. Good luck, and hope this helps.